Now, quietly. So just reading the problem, it says the pot of tea cools. Temperature of the tea is modeled by a differentiable function h. So got to make sure as you're reading that you keep straight now that they're not giving you a rate, they're giving you an amount. So h is the temperature. H is an amount, h is not a rate. Units are important. Time period, not usually super critical, but good to be aware of. Time is measured in minutes, temperature is measured in degrees Celsius. So that I want to not forget. Values of h at selected times are shown above. Any questions so far? Okay, so part A. Use data in the table to approximate the rate at which the temperature of the tea is changing at time 3.5. So approximating a rate means I'm finding an average rate of change or a secant slope. So you need to have either this written on your paper, or you could have just written the numbers themselves. So you could write 52, subtract 60, divided by 5 minus 2. That would also be fine. So if you have this red box or this red box, let's say you have to show the computations, either of those would, well, back up. This one's not going to give you any points. You have to have the numbers. So this would be 1 point. If you wrote it this way, that's fine. This would also be worth 1 point. They did specifically say that you needed units, so if you forgot, you would have been okay. Question? Please.
I just thought that
Did you show where the numbers came from, or you just wrote, okay, so you're fine then, that's fine. Anybody else? Okay, again, remember, in class, if we're working these, okay, if a question comes to mind as to why I do something, don't hesitate to ask. We're trying to score, but we're also trying to help you get better in preparation for the next time we give you an FRQ, so, or even multiple choice. So the idea is to get better and better understanding the concepts that you're being tested on. Heather?
So do we not have to write, so do we just have to write the red boxes to get the point?
Mm-hmm.
So then is it just because it says show the computations that lead to your answer rather than saying show your answer? Or like how can you tell that you can just stop there?
Gotcha. So I have to show either this red box or this one because it did say show your computation. And then a rule of the FRQ section is that numeric simplification is not required. So because after this I'd only be doing subtraction and division, I don't have to do it.
You don't have to step up.
So it's actually smartest not to. Because if you make a mistake, you'll lose the point. So it's best to just stop here and say, nope, I'm done. Please.
So I only have the H of 5 minus H of 2, but then I had negative 2.687.
That would be fine. Yeah, you can't point for 2 pebbles for Harry. You have to show computation. So what you did correctly is you showed this computation. Now I couldn't stop there, Heather, because you've got to go find H of 5 and H of 2. That's not just simplification. That's really understanding the notation and finding those values. But you did that, so you're fine. So you did both things. You showed the computations. You got the right final value. You get the point. What else? Next one. Okay. Key to success on the AP test is having the right habits. Listen to this one. Come on, look at me. Don't read everything. Read until you hit a period or comma or question mark and stop. And do whatever they ask. Don't read more. Using correct units, explain the meaning of this integral in the context of the problem. So right there you should stop. and answer the question. Don't do anything else. So they wrote this integral is, and it's back to what Julia noticed, this is average. So we're finding the average temperature of the T. You must say average temperature. You don't have to say of the T. Like that is the average temperature in degrees Celsius. You have to say degrees Celsius. And you have to say over the 10-minute time period. You could say from time 0 to time 10 minutes, but you have to say minutes.
If I just say degrees Celsius, then it's the whole point.
You will. For the meaning, when they say using correct units, they're looking to see, did you talk about every single possible unit? Olivia?
Okay, so I said that integral is the average change in temperature from 0 to 10 minutes, which is 52.95 degrees Celsius.
Gotcha. Everybody look at me. The mistake is that it really isn't the average change in temperature, it's just the average temperature.
Okay, how do you know that?
How do you know that? So that's a memorized fact, that whenever I integrate something and then divide by the width of the integral, we're just finding the average of whatever we're integrating.
Okay,
So because H is just temperature, we're just averaging temperature. It's a good question, Olivia. Two pebbles. Somebody else? Please.
If I said average value of the, like, in degrees,
Just read it to
I
me.
said, so that integral represents the average value of the temperature of the T in Celsius from T0 to T10 equals 10.
Did you say minutes?
No.
So everything was, Heather, everything was perfect except you had to say minutes. The rest of it was fine. It is the average value of the temperature, for sure. Everybody else? That was for Heather. Good question. Next one. We're supposed, because now I keep reading. Use a trapezoidal sum. So I want to make sure I don't forget it's trapezoidal. 4 subintervals indicated by the table to estimate this. Okay, rule of the AP test. If you are doing an integral, you need to write down the integral. Now, they don't always give points for it, but they often do. So I just always write it down. So I'm trying to find this integral. And I'm approximating the integral using a Riemann sum. So let's see, 4 subintervals. So we say, don't forget the 110. Riemann sum, we do 1/2. I look at the first subinterval, I take the 2 temperatures, one on the left, one on the right, add them together. Multiply by the width of that subinterval, and continue. Same thing for every subinterval. Third subinterval is 4 wide. Okay, eyes on the board. Everybody look up. Everybody look up. Everybody look up for just a second. Okay, as I said to Heather, you really want to stop. You don't want to work that out. You don't have to. Save time. You save the possibility of making a mistake. However, you've got to be cautious to make sure you have all the right parentheses or you will lose the point. I've got to have another parenthesis for that one. So as soon as I close that off, now I'm going to get this point and this point. Because I've done the trapezoidal sum, they can see it. And I've included the 1/10 because that's part of the computation. So I get both of those points.
So I have it exact like that because I have the equal sign instead of the
I think they'll let you go with that one. It is better to say approximate because the Riemann sum is always an approximation.
So I made a mistake and I wrote it down but then I fixed it when I did it in my calculator, so I have the correct like number estimate. But
So are the computations listed out like so?
no, that's wrong.
That's wrong. So they'll give you the estimate, but not the sum.
So I didn't write out the 1/2, like 66 plus 60, I just wrote out 63. Do I lose points for that?
Did you do the same thing on each of these?
Yeah, I did it for all of them.
I think that's okay. They'll let that go because they'll see you just did it in your head.
Okay.
So that's okay.
I kind of formatted it weird right here. I kind of listed each of the parts vertically, sort of organized it in my head.
I think they'll give it to you. To be safe, it would be better here just because that's the pattern. I think they'll give it to you. Alex?
If I figure out the 1/10 part, do I still get the point for the trapezoidal sum?
Yeah. Just not the point for the estimate. Anybody else? Next one. Another thing I want you to pay attention to. Eyes on me. Look up here. Come here. Come on. Again, a key to success on the AP test is taking the test the right way. So what I'll keep reminding you of is you read. You can think of something to write down. You write it down, and if that prompts you to write something else, you just keep going. As soon as you find yourself just reading, like you're not writing anything, or you're just kind of scribbling stuff, you're just starting to make things up, then you need to do something else. You save up that, don't do that making up stuff until everything else is done. Easy points count the same as hard ones. So don't get stuck on hard things until you've done all the easy stuff, or even the medium stuff. Hey, look. Hey. It says evaluate this integral, and then it has a period. So I stop there, I do not do anything else. I just say I've got to find the value of this integral. Whenever I'm asked to find the value of an integral, I remember 4 things from my flashcards. I can find the integral with a calculator if it's allowed and I have a formula. But they don't give any formula for h prime, so I can't do that. Method 2 would be, let's see, I could use, but I don't have a formula, so I can't use the antiderivative method. Third method, Riemann sum, but they always tell me to do Riemann sum, plus I don't have h. Oh, wait a minute. It's just the fundamental theorem. If I integrate h prime, that's the change in h. And h is right here, so that's all you have to do. That's 1 point. If you have this on your paper, or this, you should have an equal sign though, because you've got to show that you're finding it. If you have those blue boxes, you get the 1 point. If you forgot this blue box, I think they'll still give it to you if you have this or this written. It has to be negative though.
Why is h prime change in h? Just go over that real quick.
So that's the fundamental theorem.
Just from the come again.
Yeah, memorize fact. Whenever you integrate the rate of which h is changing, you're always calculating the change in h.
Okay.
Yep. Doubles for Adam. Anybody else? Please, Julie.
So, when you're integrating that, something is finding the area and also the average of it, right? But it's also finding a change in like h prime will find a change in h. But if you're entering h prime, that will find the area underneath h prime and also the average of h prime.
Close. Let me make a list. Hold on a second. 2 pebbles for Julia. Hey, everybody there, makes sense of this. This is a really good question. This covers a lot of different concepts that show up throughout the test. So if I integrate from negative 0 to 10, right? H prime. Okay, per the fundamental theorem, that's going to be computing the change in H. So the change in the temperature. Because H is temperature. So that's change in temperature. Not rate of change, not average, just change in temperature. And that turned out to be negative 23 degrees Celsius. Okay, come on, focus. This is not a temperature. You look at the problem, the temperature of the tea is never negative 23 degrees. It's not a temperature, it's how much the temperature changed during a given time period. That's one thing they'll ask you to focus on lots of different problems. Now if we do this one, I'll pay 4 pebbles to every single person who can raise their hand and tell me in words, what does this calculate? This one's calculating the change in temperature. This is different now. 4 pebbles if you can tell me, everybody. What does this one calculate? So what do you think?
The average changing temperature from
2 pebbles close, but they won't give you points for that. So it goes back to, and you can guess again, you can try again, Ethan. Okay, H prime is the rate of change of the temperature. We're integrating that, multiplying by, oh, I forgot to put the 0 over 10, sorry. So it's not the average change in the temperature. What is this? Let's put Jessup.
The average of rate of the temperature of heat rate.
Average rate of change of the temperature. So this is the average rate of change of the temperature. They don't ask you to find that, but that's what it is. It's the average rate of change of the temperature. The average rate at which the temperature is changing. So like if you look at the problem, the temperature goes down by 6, then down by 8, then down by 8 again, and down by 1 over different time periods. If you could average all that out, you'd say, oh, on average the temperature's dropping by like, I don't know, 3 degrees per minute or something. Okay? They don't ask you to calculate it. That's what you're finding, the average rate at which the temperature is changing. So this is a rate, this is going to be so many degrees Celsius per minute. It's an average rate at which the temperature is changing. Question. Okay, how about this one? So I already knew that before she said it. 4 pebbles. So how about this one then? And then back to your question, Julia. Yes, if we had a graph of H prime, this would also correspond to the area we see of the graph of H prime. However, area above counts positive, area below counts negative. This basically is, actually we can do it. So this negative 23 divided by 10 means that on average the temperature is changing by 2.3 degrees Celsius per minute. Negatively. Okay. This one, so let's go. You've already answered this, so I just want to pay you pebbles to remember. Just show me your hands, 4 pebbles per person. What is this calculate? Come on, show me your hands. What's this calculate? So Serena, average temperature over this time period. And we didn't calculate that, we didn't estimate it. The estimate, I didn't work this all the way. Did anybody actually plug this in their calculator? You get a number. What'd you get? 52.95 degrees Celsius. So this came out to be approximately 52.95 degrees Celsius. So this is a change in temperature. This is an average temperature. This is an average of the rate of change of the temperature. Look at it.
What about just the rate of change?
So the rate of change, let's write that down. 2 for Olivia. How many got this one for the 4 pebble? Okay. So H prime of T is just the rate of change of the temperature. At any time. Similarly, H of T is the temperature at any time. Is that your question?
Yeah, so
Keep
this
going.
might be dumb. So are we ever integrating and finding a rate of change, or no?
Hold on a second.
Like
Let me-
any
Yeah, I get what you're saying. Hold 1 second. I want to think of the best way to answer that. So don't let me forget to answer it. Hey, so H prime is the rate of change of the temperature at any time. H is the temperature at any time. If you integrate H and multiply by 1/10, you're getting average temperature. You get the average rate of change of the temperature. You can integrate H prime to find the change in the temperature. Say it one more time, Olivia.
Can you integrate anything to get a rate of change? Like, will we ever integrate?
Yeah, not commonly asked. However, if you knew the H double prime, you can integrate to find a value of H prime. So it's the fundamental theorem again. So like this. Danica's chart. If I have H prime and I want to find H, I use the fundamental theorem. So I'm going to integrate H prime. By the same exact methodology, same logic, same reasoning, if I have H double prime and I want to find H prime, I can use the fundamental theorem and an integral to do that. Is that your question?
Yeah.
That's not been asked, I don't know, that's pretty rare, but this concept is the same. It's very good. It's trouble. Please, Gary.
So on the previous page, what would happen if you just integrated H and you didn't do the average? Like, what would that do?
So if we just integrate H, we're not really finding anything that has physical meaning. So I've never seen him ask that. It's a good question. No, it's a good question. Troubles. Anyone else? Next one. Back here. So we have found the values. It says using correct units, explain the meaning. Here's the meaning. This is how much the temperature of the T decreases or drops in degrees Celsius. Time equals 0 to time equals 10 minutes. You must have you really have to have nearly word for word what they have in this box. If it's not exactly the same, you should probably ask me to verify whether you would get the point or not.
So first of all, I accidentally said water instead of heat.
You're okay with that.
Okay. And then.
They'll go like the Mormon Joe, right? It's from Utah. Anyway, go ahead.
And then, so I messed up and I did 66 minus 43, which was kind of dumb. So I said the water temperature changed by 23 degrees Celsius.
They won't read it. Yeah, they want to see that you understand that the temperature is going down. So you have to say decreases, drops, cools, something like that. Anybody else? Please.
This is small, but you have to say from T to 0 to T of 10, or can you say in 10-minute time? You have to have the correct.
Right. I think it's best to say start and end because it's the most specific. But I have seen them allow over the 10-minute period. So you'd be okay. Please.
So if I just say change is negative, I need to have actual word like decreasing.
They want to see decreasing. Anybody else? Next one. Time equals 0, the biscuits with temperature 100 degrees. So we got 100 degrees for the biscuits. Were removed from an oven. The temperature of the biscuits at time t is modeled by a function b. here's my, oh, and that gives me B prime. So really, Olivia, this is basically the same concept that you were asking about, although it's not giving you B double prime, but it's the same idea. Using the models, hey, so I'm supposed to use this. At time equal 10, how much cooler are the biscuits than the T? So time equal 10, the biscuit temperature is 43 degrees. No, sorry, the T temperature is 43 degrees. So I'm supposed to figure out so I got to find the biscuit temperature at that time. So fundamental theorem. So I integrate from time 0 to time 10, B prime. That will tell me the change in B. Again, you will never see this question again. You will likely never see anything even worded similarly. The concepts you will see again. If you have any question about the concept, speak up. Pretty good? So I rearrange as I did before. So this is 0 to 10. This will be B of 10. Subtract B of 0. So rearranging, you get B of 10 is equal to B of 0, which is 100. Wait a minute here. Yeah, so we move this over, that would be 100, right? Okay, so if they see that you're integrating B prime from 0 to 10, they're going to give you 1 point. If they see that you remember to do 100 plus, you get the second point. So any questions to here? So I've got 2 points so far. If I run that through my calculator, I'm going to get B of 10. Oh, come on. B of 10 is going to equal, turns out to be 63 point, I do that in my head. Oh, B of 10 is this, 34 minutes, sorry. What the heck? Sorry. B of 10 is 34.18. Thank you. Another habit you should have on the AP test. Reread regularly. Like I've done some work, I need to go back and just make sure I'm doing the right thing here. I found the temperature of the biscuits, but that's not the question. So I stop there, I do not get the point. It says how much cooler are the biscuits than the T. So now I can compare these two numbers and write down biscuits. I already spelled biscuit. Thank you. Biscuits. What number do you get for this? Somebody's got it. 8.8. Oh, okay. Where did I write it? Questions from anyone?